We are looking at Math 150, Appendix A, Section 6. This is a review of the rational expression. So remember that a rational expression is a polynomial divided by a polynomial. And here are some examples. X minus 2 over 4, 4 divided by x minus 2, x over x squared minus 1, and x squared plus 1 over x squared plus 2x minus 3. A complex fraction is a rational expression divided by a rational expression. Or an easy way to say this, it's just a fraction divided by a fraction. So we're going to be working with these just a little bit later. The first thing that we want to do is we want to remind ourselves, how do we simplify, or how do we multiply rational expressions? Well, if you remember, the first thing that you need to do is that you need to factor. And because you're going to factor, and then you're going to reduce, and then you're going to multiply. And the factorization of the numerator here is x plus 3 times x minus 2 divided by x plus 5 times x minus 1 times, now that's the difference of squares, so this is x minus 5 times x plus 5, and then this is x minus 5 times x plus 3. And then when you multiply, if you remember, what it does is it takes it all the way across, makes it a single fraction under multiplication. Now we reduce out commonalities, in other words, we form ones. So x minus 5 reduces out with x minus 5, and x plus 3 reduces out with x plus 3, and x plus 5 reduces out with x plus 5. And so what we're left with in the numerator is x minus 2 divided by x minus 1. And that's your final answer. Now, when you're dealing with complex fractions, and we remember that what it is a rational expression divided by an rational expression, or a fraction divided by a fraction. Now, this is a single fraction. This is a single fraction. So the issue here then becomes, all we need to do is to just invert and multiply, so that this becomes then 9x squared plus 3x minus 2 divided by 12x squared plus 5x minus 2 times, now invert the denominator, 8x squared minus 10x minus 3 over 9x squared minus 10x minus 3. These factorizations are just a little bit more complex, so we got to think about it just a little bit. So we're going to do just like we did in the previous problem, factor, and I try to look to see, at least for the moment, what looks to be the easiest for me to factor. And let's see, this looks like here, this is going to be a 1 and a 2, can't be anything else than that. This is a 3x and a 3x, and let me check the inner outers. This is a 6, this is a 3, and then 6 minus 3 is 3, so I'm correct. So I need the plus here and the minus there. So following along, looks like we're going to have 3's. So this is going to be a 3x and a 4x. And then I need to be able to place the 2, a 2 and a 1. So check the inner outers and see if I get the, this is an 8 and a 3. I do get 5, but I need a plus 5. So this is plus, this is minus. Well, let's see, 4x and 2x, and now I need to place the 3 and the 1. So 12 and 2 is going to give me 10, so the 3 is here, and the 1 is there, and I need a minus 10, so that's going to be a minus 12 and a plus 2. Gives me a minus 10. 3x and 3x. Now I chose all the 3x's because that seems to be what the theme of this problem is. And 3x and 3x. And then we're looking at needing to get a 10 in the middle. And everything is subtracted. Ooh. 3 can't go there, 3 can't go there, so it can't be 3 and 3. And that's my only choice. Oops, it would help if I copied the problem down right, wouldn't it? This is a 6. Whew. So, and it still can't be 3 and 3. I always got a common factor of 3. Can't have a common factor of 3. This is 1. Alright, I think we have it now. So this is then a 3 and a 3, and a 1, and a 1, and a plus, and a minus, and a minus. And I think we finally have it, and that's what happens sometimes. And when I wouldn't factor, I had to check to see, and I did indeed copy the problem down wrong between here and here. So now reduce 3x plus 2, and then 3x minus 1. I can only take one of them. And let's see, is anything else up? Look at that, 4x minus 1, 4x plus 1, nope. And then these guys don't go. So what I'm left with is a college algebra ugly answer, 4x plus 1 times 2x minus 3 over 4x minus 1 times 3x minus 1. And then that's going to be my final answer.